Hi, today we discuss the LeetCode problems number 3, longest substring without repeating characters. Given a string S, find the length of the longest substring without repeating characters. So this question asks you to return the max length of the substring. For example here, in the example number 1, it returns 3 as the longest length. And the characteristic of this substring is it's without repeating characters. For example, the substring in the example number 1, ABC, all the characters in this substring is not repeating. But if you add one more character, A, into the substring, then it will be invalid because A appeared twice. Let's analyze the problem with an example. For example, we have a string A, B, C, D, B, A. To find the longest substring without repeating characters, we need two indices to mark the beginning of the substring and the end of the substring we have found so far. For example, we have found a substring A, B, C without repeating characters. So the index on the left, we call it left, and the index on the right, we call it right. What we do the next is we'll move the right index to the next character. Now it's D. Then we need to check if D already exists in the substring we have found. The substring we have found so far is ABC. D doesn't exist in this substring, so we have a new substring with a greater length. So the length of the previous substring was 3. Now we have a new substring with the length of 4. Then we keep doing the same process by moving the right index to the next character. This time, the right index pointing to the letter B. We ask the question again, does B exist in the substring we have found so far? Then the answer is yes. We found B here. It's within the boundary of the last substring we have found. So at this point, we need to move our left index to a new position which excludes the previous B. Now we have a new substring which is bounded by the left and the right indices. It's from C to B. The length is 3. Then we move the right index to the next character, which is A. The letter A was visited before at the beginning of the string, but the previous A doesn't exist in the boundary defined by left and the right indices. We can safely include A into our substring to form a new substring, and we don't have to update our left index. So now the right index moved to the last character in the string, and the new substring has a length of 4. And our loop can stop here. From this example, we can see that the longest substring without the repeating characters is the substring A, B, C, D, or the substring C, D, B, A. We can return the first substring with the length 4 as our answer. From this example, we can see that we keep moving the two indices left and right to the right direction. This technique is called a sliding window. And when we visit each character in the string, we need to check, is this character visited before? and does it exist in the boundary of the last substring. For that check, we need to keep track of the position for each character in the string. One way to keep track of the character in the string is to use Hashmap. And for our Hashmap, we can use the character as a key and use the index as a value. For example, when we visit A, we put A in the Hashmap and we record the position of A in the Hashmap. And the same for the B and the C, D. And when we visit the B at this position, when we check the Hashmap, we found the B already exists at the position 1. We need to update the left boundary from 0 to the position on the right side of B, which is 2. And then we update the Hashmap with the new position of B, which is 4. And this question only asks us to return the max length as the answer, so we don't care if it's a substring here or the substring here. Both substring has a length of 4. We only need to return 4 as our answer. So we also need to keep track of the max length we have found so far. Let's create a pseudocode. We need a for loop to visit each character in the string. And in the for loop, we will keep 2 indices. The first is the index for the right boundary. A second is the index for the left boundary. And in our for loop, we will move the right index to the next character. And our process will end when the right index reaches to the end of the string. And we will move our right index to the next character. Inside of the for loop, the first step, we need to check if the character exists in the last substring. And for this step, we need a Hashmap to keep track of each character in the string. So before the for loop, we need to declare a Hashmap. If the character we are visiting exists in the last substring, then we need to update our left boundary with a new position. The next step is we will keep track the character in the Hashmap. If the character already in the Hashmap, we need to update the character in the Hashmap with the new position. If it doesn't exist, then we add this character and its index into the Hashmap. Then the last step is we need to calculate the substring length and update the max length. To keep track of the max length, we need to declare a variable before the for loop. So this integer variable max keeps track of the max length of the substring we have found so far. These are the steps to find the longest substring without repeating character. Next, we'll use the same example we discussed before to examine our pseudocode. Here is our string A, B, C, D, B, A. Then we have two indices. Here is the left and the right. Okay, when we start our process, both indices pointing to the first character in the string. Here are the index for each character in the string. 0, 1, 2, 3, 4, 5. And here we need to keep track of the max length of the substring. And we only update the max length when the length of the substring is greater than the max. We need to compare the max with the length of the substring. It's right minus left plus 1. So if right minus left plus 1 is bigger, then we will update the max. And we also need to keep track of the left index. In the beginning of the for loop, we're visiting the letter A. First, we need to check if the letter A was visited before. A is not visited before, so we keep track of A and its index in the Hashmap. Then we calculate the substring length and update the max. The substring length is 0 minus 0 plus 1. It gives you 1. And the initial value for max is 0. The 1 is greater than 0, so we update the max with 1. And the left is 0. Then we move the right index to the next character. Then we check if B was visited before. B is not in our Hashmap. Then we add B and its index in the Hashmap. Then we calculate the substring length. It's 1 minus 0 plus 1 is equal to 2. So the substring AB has a length of 2. So we compare 2 with the max length 1, so 2 is greater than 1. We update max with 2. Then we move the right index again. C is not in the Hashmap, so we add a C in the Hashmap. And here is the length of the substring is 2 minus 0 plus 1. It gives you the 3. And the left remains at 0. So we update the max with 3. Then we move right again. D is not in the Hashmap. Then we add D in the Hashmap. And the length of the substring is 3 minus 0 plus 1 equal to 4. The left is 0. And 4 is greater than the max, and we update the max with 4. Then we move the right index to the next character, B. We check the Hashmap table. We find B at the position 1. So we need to check if B is within the boundary defined by the left index and the right index. So which means the previous position of B is greater than the left. So here we'll compare Hashmap get the position for the current character. If the previous position is greater than left, then we will update left with the previous position plus 1. So here, the previous position for B is 1 and plus 1. Then we update the left index with 1 plus 1, which is 2. So which means we will move the left index from 0 to the position 2. So by doing this, we are excluding the repeating character from the previous position. And then we update the B in the hash map with the new position, which is 4. Then we calculate the length of our new substring, 4 minus 2 plus 1 equal to 3. And 3 is smaller than 4, and we do not update max. So max remains as 4. Then we move the right index to the next character. We check the letter A if A is in the hash map. We found A in the hash map. The previous position is 0. So A is here. But we do not want to update the left index because the position of previous A is outside of the left boundary. We have a boundary here. And this A is outside of this boundary, so we do not update left index. But we will update A in the hash map with new position, which is 5. And then we calculate the length of the substring. 5 minus 2 plus 1 equal to 4. 4 is equal to the max, so we do not update max. And the left remains as 2. And at this point, the right index reaches to the end of the string, so our for loop stops here. When we exit from the for loop, we have 4 as the max length of the substring. Then we will return 4 as our answer. The time complexity of our solution is big O n because we have only one for loop to go through each character in the string once. Next, we'll go to the LeetCode website to implement the solution based on our pseudocode. Here is the pseudocode I prepared in the LeetCode website. We have for loop here to visit the character in the string one by one. And before the for loop, I declared an integer variable called max. So this variable keeps track of the max length of the substring. I also create a hash map called map, and it uses the character as a key and the integer as a value. So in the map, we're going to use the character to find out its index, which is the position in the string. So in the for loop, we have 2 indices defined. First is the index for the right boundary, we call it right. And we also have an index for the left boundary, we call it left. And in the for loop, we will keep move the right index to the right. Once we enter the for loop, the first thing we do is to check if the character at this position is visited. So we do the check in the Hashmap to see the Hashmap contains the character. If we find this character in the Hashmap, then we will update the index with greater value. So we will compare the current value of left index with the position of the repeating character in the Hashmap. If the previous position of the same character is greater or equal to left, then we will update the left with the previous position plus 1. Otherwise, left remain the same. And here we'll update the left index with the bigger value of these two. The next step is to keep track of the character and its index in the hash table. And the last step is we'll calculate the substring's length and update the max if the length of the substring is greater than the current max value. So here we'll compare the length of the substring, which is right minus left plus 1. And we'll compare this value with the current max value. And we will use the max function from the math library. So this function returns the bigger value between these two. Then we will update the max with these two. After we visit all the characters in the string, we'll return max as the output. Okay, this is the implementation based on the pseudo code. Let's test our code. It passed. Let's submit the code. Our solution has runtime 4 milliseconds and is faster than 88% of all the online submissions. Runtime is 4 milliseconds and the ranking is 88%. Next, we'll discuss how to improve the performance of our solution. In this solution, we use the Hashmap to keep track of each character and its position in the string. A better way to track the characters is to use integer array. Each character has an ASCII code, which is integer value. This is the decimal ASCII chart I found in the ASCIIchart.com. For example, the letter A has a corresponding integer 97, and the B has an integer value 98. Let's say we have an integer array to keep track of the last position of the characters. We call it last position. And it's an integer array. So if we want to reference the letter A, we can simply use its ASCII code as the index of the integer array. So when we reference last pose with integer 97, it's reference the letter A. In this hash table, we have recorded the last position of A is 5, the last position of B is 4, last position of C is 2, and D is 3. When we use the integer array, it will look like this. A will be referenced in the position 97, And the 98 reference the character B. 99 is C. And 100 character D. The value at the position 97 will be 5. And here is 4. And here is 2. And here is 3. The reason the integer array can perform better than the hashmap is because in the hashmap, it will first convert the key into a hash code, and then use the hash code to look for its value. But if we use the integer array, we simply use the ASCII code to reference the value. Let's modify our solution in the LeetCode website to replace the hashmap with an integer array. Here is the implementation of our last solution. We're going to replace all the hashmap code with the integer array. First, we'll declare an integer array called the last position. We initialize this array with a size of 256. And then we initialize this integer array with -1. The reason we initialize the array with -1 is because in our input string, the lowest position is 0. So we have to initialize the array with a number smaller than 0. In the for loop, the first step is to convert the character into an integer. To do so, we need to declare an integer variable called position, and we initialize the position with 0. And here, we assign the pose with the character in the input string. By assigning a character to an integer, the character is converted to the ASCII code. In the next step, when we use hashmap, first we need to check if in the hashmap the character exists. Then we update the left index with a bigger value. When we use the integer array, we can simply compare the position of the character with the left index. So we only update the left if the last position of the character is greater or equal to left. So here, we update the left index with the last position plus 1. And then we update the position in the integer array. This is all the change we need to do. Let's test the code. The test is successful. Let's submit the code. Our submission was successful. The runtime is 2 milliseconds and is faster than 99% of all the online submissions. With the change of integer array, our submission in the LeetCode improved from 4 milliseconds to 2 milliseconds. It was faster than 99% of all the online submissions. That's all we discussed today. Thank you for watching.